India's tryst with space technology began in 1970s with the launch of sounding rockets and the famous sight experiment when television entered the home of common man through a satellite. Again, during 1970, ISRO successfully carried out a path-breaking experiment for detecting coconut root wilt disease in Kerala using color infrared aerial photography from a helicopter. This triggered the idea of carrying out such observations from a satellite, and thus the Indian Remote Sensing Satellite Program was conceived. Since then, various user segments like agriculturists, forestry, town developers, agencies managing disasters, meteorologists, and many others projected more and more needs. ISRO was thus driven by the user needs to develop the program further. The first operational Indian remote sensing satellite, IRS-1A, was launched in March 1988. This was followed by IRS-1B, IRS-1C, IRS-1D, OceanSat-1 and OceanSat-2, Saral, Cartosat, RISat, and many more. All of these satellites are placed in a low Earth orbit and they move with respect to Earth in a periodic way. Over the years, launch vehicle technology has also evolved in steps, and a number of vehicles like SLV, ASLV, PSLV, GSLV Mark 1, Mark 2, and recently the success of GSLV Mark 3 with 4-ton lift capacity to GEO has placed our country on high pedestal among the Committee of Nations. PSLV is the proven workhorse launch vehicle of India. It has launched 46 Indian and 180 foreign satellites in a span of 23 years. It is also the first Indian launch vehicle to be equipped with liquid stages. The design of PSLV is highly adaptable and its configuration is possible to be changed as per requirement. PSLV was instrumental in several landmark missions of ISRO, which include Chandrayaan-1, Mars Orbiter mission, and the recent Indian Regional Navigation Satellite System, NAVIC. The performance and adaptability of the PSLV has been improving with every succeeding mission. PSLV-C2 launched 3 satellites, C11 launched 10 satellites, C34 placed 20 satellites in multiple orbits, and of course, the momentous PSLV-C37 mission, which launched 104 satellites in one go. For utilizing its capacity to the maximum, the PSLV-C38 mission will launch 2 Indian satellites, namely a Cartosat-2 series satellite. This satellite will be placed into a 505-kilometer sun-synchronous polar orbit. It will also carry an Indian student satellite, NIU-SAT, of Nurul Islam University, weighing about 15 kilograms. The mission will also carry 29 foreign satellites from various countries. There are 10 satellites from United States of America, 3 each from United Kingdom, Italy, and Belgium, 1 each from Japan, France, Germany, Finland, Chile, Austria, Slovakia, Czech Republic, Lithuania, and Latvia. The Cartosat satellite is the 6th and the latest in a series of advanced Indian remote sensing satellites built by ISRO, mainly intended to augment remote sensing data services to the users. It is a 3-axis stabilized satellite and is configured with an objective of providing images in panchromatic and multispectral bands. The spacecraft carries a panchromatic camera, a 4-band multispectral camera, and 2 event monitoring cameras. The main frame of the satellite consists of power system, data handling system, telemetry and telecommand system, on-board control unit, attitude and orbit control system, and the mechanical systems like spacecraft structural elements and thermal system. The satellite structure also contains the mechanisms for solar array deployment and dual gimbal antenna mechanism. Solar panels of the spacecraft generate about 986 watt power, which is supported by lithium-ion batteries. The imageries from the spacecraft will be used for cartographic applications, urban and rural applications, coastal land use and regulation, utility management like road networks, water distribution, creation of land use maps, change detection to bring out geographical and man-made features, and various other LIS and GIS applications. This Cartosat satellite is expected to provide remote sensing services to our country for around 5 years. It is all set to soar into space aboard PSLV-C38 from Satish Dhawan Space Center, Shar, and score yet another victory for ISRO's most dependable, the Polar Satellite Launch Vehicle, PSLV.